Hi children, how are you all? I hope all you are fine. Children, in that previous video we discussed up to that first concept, all the worksheets we learned, right? In this video we are going to start that worksheet 1 from that second concept. What is the second concept here? That is whole numbers. From that whole numbers here, the worksheet 1, first question, let us see here what they given. The false statement among the following is, okay, here some statements they given related to that whole numbers, natural numbers, integers and real numbers. And I think so already you know about that natural numbers and whole numbers and some other types of numbers also, right? Integers and so and so. Okay, let us see here what is the first option they given. Set of real numbers is not finite. So real numbers means that is also a type of numbers, right? In that real numbers we have natural numbers, whole numbers, integers all together, which means rational numbers, irrational numbers, all together numbers are known as real numbers. Okay, so in that real numbers we are having that those many numbers, then how we can say that that is a finite? That is not finite means that is infinite only, no? Okay, set of real numbers is not finite. What is the meaning of not finite? Not finite means infinite only, no? Okay, that is the first option. Come to that second one. Set of whole numbers is not finite. Here, not finite means not infinite. These are the meanings. Okay, not finite means not finite, which means infinite, and not infinite means finite. Okay, let us see here what is the second option. Set of whole numbers is not finite, which means set of whole numbers are finite, they are saying. So obviously we know that that is wrong statement only. Why? Because set of whole numbers means W is equals to set of the starting whole number is 0 only, now the smallest whole number 0, 1, 2, 3 and so on. What is the greatest number? Children, just observe that except 0, here we are having 1, 2, 3, 4 and so on. These all are the set of natural numbers only, no? In that set of natural numbers, what is the smallest natural number? That is 1. What is the greatest natural number? That is infinite. Okay, we cannot say that what is the greatest number. Okay, and greatest natural number. That's why we cannot say that what is the greatest whole number also. Okay, ma. That's why here what they given in that statement 2, that is wrong. Okay, is not infinite they given, which means a finite they are saying. That's why that is the wrong statement. Okay, and see here, set of natural numbers is infinite. Yes, obviously. Set of natural numbers infinite, 1, 2, 3 and so on. Okay, set of natural numbers is infinite. Next, set of integers is not finite. Okay, set of integers is not finite. So among them here what they are saying, ma? Set of integers is not finite means what here? Infinite. Obviously that's one also we know that, right? Integers I or z. I or z is equal to set of integers and so on, -1, 0, 1 and so on. Here also we know that a set of integers are not finite means infinite. So as per that given statements, the first one real numbers, Numa. So real numbers R is equals to here set of natural numbers, whole numbers, integers and so on. Okay, integers, and in the same way rational numbers and irrational numbers, those all the numbers are there in that real numbers. Okay, as per this one here, set of real numbers is not finite means set of real numbers is infinite. So we know that this is the correct statement. Okay, and second statement is wrong. Next, set of natural numbers is infinite. Yes, of course, set of natural numbers is infinite. So as per this one, next third option also correct only. And set of integers is not finite means set of integers is infinite. Yes or no? Here set of integers is also infinite only, no? So that's why here this is also correct statement. Now here what is the false statement, ma? Here the false statement is option B. Okay, so among them what they are asking here, the false statement among the following is. So as per this one, what is the correct answer here? Correct answer is option B as per the question. Why? Because in that question they are asking false statement. So what is the false statement among those four? B only, no? So that's why here the statement what they given in that B option, that is the wrong statement. Understood, ma? So this is the explanation for this one. And here what is that answer here? Option B is the correct one. Clear? Next. Second one. Successor of 0 in the set of whole numbers. In the set of whole numbers, 0 is there, no ma? 0 is that smallest whole number. Yes or no? What is the smallest whole number? 0. Now what they are asking here? The successor of 0. So successor means what? Successor of 0 is 0 plus 1, which is equals to 1. Yes or no? Successor means adding 1, which means just after number or next number. Next number of the given number or after number of the given number. Understood, ma? Or otherwise the successor of 0 is plus 1. If you add 1 to that any given number, then you will get that successor of the given number. If you subtract 1 from any number, then you will get that predecessor of any number. Okay? So as per this one, what is the answer here? Option C is correct, that is 1. Understood? Yes. Let us see here question number 3. In the set of whole numbers, the valid operation among the following. So we are having here in that whole numbers, we have some properties, right? What are the properties, ma? Closure property, associative property, commutative property, distributive property. Okay, so these all, and in the same way we are having some other also, additive identity, additive inverse. But here additive inverse not exist and additive identity exists here. Multiplicative identity exists. Multiplicative inverse does not exist. Okay, this is all the concept we learned at the time of synopsis, right? So as per that synopsis here, they are asking in the set of whole numbers, which type of operation is valid here. Okay, just to say that directly also you can find that, otherwise if you want to simplify this one, then also you can simplify that. Okay, when you observe that these all four options, okay, simply here we can observe that A divided by B is equal to B divided by A. The first option is A divided by B not equals to B divided by A. Yes or no? In whole numbers. Just example say that, ma, here 4 divided by 2 not equals to 2 divided by 4. Yes or no? 4 divided by 2, which is equals to 2. 2 not equals to 2 divided by 4, which means 2 by 4 means 1 by 2. Understood, ma? So 2 is not equals to 1 by 2. We know that. So that's why here this is the first option. What they given here is equal to they given, but here is equal to not satisfies. Okay, as per that option they given here is equal to, but A divided by B not equals to B divided by A. This is the correct statement. Understood, ma? That's why here option A is wrong. Next, option B, what they given here, 12 minus 2 is equal to 2 minus 12. Okay, or else if you want to take the same example, then also you can apply here same example, ma. 12 divided by 2 is equal to 2 divided by 12 they given. Okay, 6 not equals to 1 by 6. Understood? That is the first option. And come to that second option, that one they given as 12 minus 2 is equal to 2 minus 12. Okay, which means here 12 minus 2, which is 10 is equals to minus 10. This is not possible, no? 10 not equals to minus 10. So that's why here A minus B not equals to B minus A. This is the next statement. Understood, ma? But here they given that is equal to. That's why this is also wrong statement. Am I clear? And come to that next one here, 0 plus 8. So what is that? 0 plus 8 is equals to 8. We know that, right? As per that additive identity, if you add 0 to any number, then you will get the same number itself. Yes or no? The resultant is again the same number itself. So as per that one here, this is satisfying. Option C is satisfying here. This is the correct one. Understood, ma? And come to that next option D here, 3 into 1 is equals to 1 into 3. Okay, but here they are saying that 3 into 1 is not equals to 1 into 3. 3 into 1 is equals to 3, and in the same way 1 into 3 is equals to 3. Therefore, 3 into 1 is equals to 1 into 3. But as per this one here, they given that wrong statement. Understood, ma? That's why which option is satisfying here? Option C is satisfying as per that additive identity property. As per that additive identity property. What is the additive identity element? Additive identity element is 0. Okay, here I will ask you one question. What is that? Is there additive identity element exist in that natural numbers? Or in natural numbers, what is the additive identity element? Children, here answer is it does not exist. Why? Because we know that in natural numbers, we don't have that 0. Okay, in the set of natural numbers, 0 is not there, right? That's why additive identity element actually that is 0. So that's why here additive identity element does not exist in that natural numbers, in the set of natural numbers. Okay, when onwards we will take that one from that whole numbers onwards. Why? Because in that whole numbers only we are having that 0. Next, in that integers, it is satisfies or not? Of course satisfies. Why? Because in that integers also 0 is there, no ma. So that's why that is also satisfies, except that natural numbers, remaining all the types of numbers having that 0. Okay, so we can say that in that remaining all types of numbers, additive identity element exists except that natural numbers. Understood, ma? Yes. So here answer is option C. Come to that fourth question. What is that? The property related to the given given operation 7 plus 0 is equal to 0 plus 7. Okay, as per this one here we can say this is in the form of a plus b is equals to b plus a. Okay, but some cases you can say that here ma'am you are adding that 0 to this number, then again you will get that same resultant. Actually here if you add 0 to any number, then you will get the same number itself as the resultant. That is additive identity property. Okay, but here a plus b is equal to b plus a. Here b is equal to 0 they taken. Why? Because a comma b belongs to whole numbers. A is a whole number and b is a whole number. So we can take at the place of whole numbers, we can take 0 also, no? So as per this condition here we can say that this is in the form of commutative property under addition. Which property, ma? Commutative property under addition. Okay, so which one is that answer here? Option A is correct, that is commutative property under addition. Clear? Next, let us see here question number 5. The largest whole number, it's a predecessing, yes, predecessing 10 to the power of 8 plus 1 is the largest whole number predecessing. Okay, so what is the meaning of this one? Here say that what is the predecessor of this number? Okay, they are asking predecessor of. Predecessor of 10 to the power of 8 plus 1 is. Children, actually what is the predecessor meaning? Predecessor means minus 1 only, no? Just before number. Okay, simply here predecessor means minus 1. If you subtract 1 from that any number, then you will get that it's a predecessing number, right? So 10 to the power of 8 plus 1, if you subtract 1 from this one, if you subtract 1 from that number, then you will get that predecessor. So here plus 1 and minus 1 gets cancelled. Finally here answer is 10 to the power of 8. But here in that option C here, 10 to the power of 8 minus 1, here we should not subtract 1 from that 10 to the power of 8. Okay, here we have to subtract 1 from 10 to the power of 8 plus 1 minus 1. Why? Because here 10 to the power of 8 only not there. 10 to the power of 8 plus 1 is the complete number. From that complete number only just you have to subtract 1, then only you will get that it's a predecessor. Right? So that's why 10 to the power of 8 plus 1 minus 1, then you will get again 10 to the power of 8. Understood? Then here first option is wrong and the second one is also wrong. Come to the third one, they given as 10 to the power of 8 into 1. Again you will get it as 10 to the power of 8. Yes or no? Actually our answer is 10 to the power of 8. But as per that given option, that is multiplied by 1. If you multiply 1 with any number, then you will get the same number again itself. Okay, then that is called multiplicative identity. Okay, then what is the multiplicative identity element here? That is 1. Is multiplicative identity element exist in that natural numbers? Yes, of course. Why? Because in that natural numbers, what is the smallest natural number? 1 only, no? So 1 existing in that natural numbers, as usually here multiplicative identity also exists in that natural number. Clear, ma? Yes. So what is that answer here? 10 to the power of 8 into 1. Okay. Let us see here next one. Question number 6. The set of whole numbers contains a dash number of elements. See here, ma. Whole number set is containing 0, 1, 2, 3 and so on. Okay. And so on means up to infinity only, no? Yes, I know. What is the greatest number? We doesn't know that, right? So that's why here W is equals to set of 0, 1, 2, 3, 4 and so on up to infinity. So how many numbers are there in that set? Infinitely many numbers are there. So as per this one, which option is correct, ma? Infinite. Children, here limited, finite, fixed number, these all are having that same meaning. Understood, ma? Yes. Which option is correct here? Infinite. Option A is correct. Next one. Yes, see here. Commutative property of multiplication. Commutative property of multiplication in whole numbers is represented by. So what is the commutative property under multiplication here they are asking, no? Commutative property under multiplication. Okay, under multiplication symbol they are asking. So commutative property under multiplication is A into B is equals to B into A. Okay, the product of any two numbers in any order is always satisfies. Okay, which means here A into B is equals to B into A. Okay, ma? A into B is equals to B into A. That is a commutative property under multiplication. Now the same one where they given here. Yes, A into B not equals to B into A. But we are saying A into B is equal to B into A. Just example, 2 into 3 is equals to 3 into 2. 6 is equal to 6. Satisfying or not? Obviously. Okay. So that's why here this is the wrong statement. And A into 1 by 0. Here you may get the doubt. Here this one 1 by 0 we can take it as B also. But here 1 by 0 is undefined. Okay, that is undefined. That's why we should not consider it as a whole number. Understood, ma? 1 by A, that is not there at the place of 1 by A does not belongs to whole numbers. 1 by A belongs to rational numbers. 1 by A belongs to rational numbers. That one does not belongs to whole numbers. That's why here second option also wrong. And first one also wrong. Next 1 by B, 1 by A. That's what I'm saying here. 1 by B, 1 by A belongs to rational numbers. But here we are discussing about that whole numbers. Understood, ma? Yes. That's why here which option is correct? A into B is equals to B into A. Next. Let us see here right one. Additive identity in whole numbers. That's what previous we discussed. What is the additive identity element? Additive identity element in natural numbers, whole numbers, integers, and so on. Okay, so here additive identity element in natural numbers does not exist. Does not exist. And here in whole numbers, additive identity element is 0. Okay, and in the similar way, remaining all the types of numbers, all the set of integers, also all the set of integers and rational numbers, irrational numbers, everything. Okay, here what is that additive identity element means? That is 0 only. Okay, except that natural numbers. Now what they're asking, additive identity element in whole numbers they're asking, so that's why here answer is option C. Am I clear, ma? Yes. Let us see here next, 9th one. Here say that 7 plus 3 plus 8 is equals to. So actually here the question is in the form of A plus B plus C is equals to A plus of B plus C. Okay, here for any integers or for any whole numbers, for any 3 whole numbers, A, B, C. Okay, here the condition is A plus B plus C is equals to A plus of B plus C as per that associative property. Associative property under which fundamental operation here? Under addition or subtraction, multiplication or division. Which one is there here? Which symbols are there, ma? Here plus symbols only. No, plus symbols means that is nothing but addition. So under addition. Am I clear, ma? So as per this one, what is the answer here? A plus B, A plus of B plus C. So 7 plus 3 plus 8, which is equals to 7 plus of 3 plus 8. This is the correct answer and this is the explanation. Understood, ma? Which one is correct here? A plus of B plus C. Option D is correct, that is 7 plus of 3 plus 8. There is no change in that order, just there is a change in its grouping way. Okay, way of grouping the numbers. In that way of grouping the numbers only difference is there, but there is no change in its order. Okay, here we are not changing the order. If you add that first 2 numbers, if you add first 2 numbers, then what you will get? 7 plus 3 plus 8. 7 plus of 3 plus 8. As per this one, 7 plus 3 is equal to 10 plus 8, which is equals to 7 plus 8 plus 3 is 11. Okay, as per this one here, 10 plus 8 is 18. 7 plus 11 is 18. Just see here, answers are same. Both the sides having that same answer only. But here the process is different. See here. 7 plus 3 is equal to 10. So 10 plus 8 is equal to 18. And in the same way, if you add next 2 numbers, 2 and 3 numbers, okay, second position, third position numbers, if you add, then you will get here 11. And the first position number, if you add to that resultant, you will get that 18. Okay, as per this condition here, we are getting the same answer or not? So here we are not changing the position of the numbers or order of the numbers. We are not changing here. Just there is a change in its grouping. Okay, grouping them in a different way. Understood, ma? So what is that answer here? Option D is correct answer. Clear? Yes. Next, 10th question, what is that? If A and B are whole numbers, then A plus B. Okay, A and B are any whole numbers, any 2 whole numbers, which means A plus B belongs to whole numbers. A plus B belongs to whole number. Why? Because A comma B belongs to whole number. No. A comma B belongs to whole number. Then easily we can say that A plus B is also belongs to whole number. Why? Because let A is equals to 5, that is a whole number. B is equals to 100, that is also a whole number. Then A plus B is equals to 5 plus 100, which is equals to 105 is also belongs to whole number. Yes or no? Okay, as per this condition here, we can say that A comma B belongs to whole number. Then A plus B is also belongs to a whole number. Okay, as per the options what they given, cannot be a natural number. Why? Because here 105 is a natural number. Of course, natural number is a whole number. Here in that set of whole numbers, only 0 is there. What is the difference between natural number set and whole number set? Means in that natural number set, the smallest number is 1. And in that whole numbers, what is the smallest whole number? Means 0. 0 only added. Along with that 0, left over all the numbers are natural numbers only, no, in that whole numbers. So as per that condition, here we can say that 105 is a natural number, that is a whole number. Okay, 105 belongs to natural number, 105 belongs to whole number. Okay, is not a whole number they are saying, that's why this is also wrong. Statement A also wrong. And is a whole number. Yes, of course, this is correct answer. And is not possible. Why? Because it is not possible. Just we are taking the sum of those two numbers only, no. A is a whole number, B is a whole number. Of course, if you add those two whole numbers, again you will get a whole number only. Understood, ma? So that's why here is not possible. Why it is not possible? It should be possible here. Okay, ma? As per this one, what is the answer here? Option C is the correct one. Clear? Yes. So children, in that first worksheet, up to 10 questions there. So in this video also we discussed up to 10 questions. In that next video, again we will meet with the next worksheet 1A. Okay, thank you all.